Good day, Sadie. So far we have talked about what is a force on our previous lessons. We talked about what a force can do, and that the force can be classified as contact force or non-contact force. So again, we talked about different types of forces in physics, where we had normal force, frictional force, static friction, tension, and we also discussed how to draw a force diagram as well as a free body diagram. So today I want us to look at the application of Newton's law. So the first thing that I want you to do is pause the video, try the question and see if you can get it right. Then after, play the video. So let's look at the first question. The first question says, a stationary car with a mass of 1000 kilograms. The car is subjected to a horizontal force with a magnitude of 200 Newton. There is a frictional force of magnitude 50 Newton between the surface and the car tire. And question number 1 stated that draw a force diagram depicting all of the forces acting on the car. Number 2, it says determine the vehicle's acceleration. So when we talked about force diagram, I said what are the few things that you must show. You must make sure that your diagram is large enough, and the magnitude of the arrows, the length determines the magnitude, and also you must label your arrows. So here we are talking about a car that is stationary, is not moving, and they give us the mass of the car. So if the car is stationary, the question will be how many forces are acting on the car. Let's answer number 1, a force diagram. This will be the solution for number 1. We are required to draw the force diagram. So we draw the object dealing a car. That's our object. It's stationary. Then if it's stationary, there's only how many forces that is acting on the car? Is the normal force, which is Fn, and the force of gravity, which is Fg. So because of the car is not moving up and down, then the area of Fg must be the same as in terms of length of Fn. That's a car that is stationary. So again, it continues. The car is subjected to a horizontal force. So if it's subjected to a horizontal force of magnitude 200 newtons, let's say the force was subjected to the right, then a force of magnitude, this is the force applied, to the right of magnitude 200 Newton. And they said again, there is a frictional force of magnitude 50 Newton. And we know that frictional force acts in the opposite direction to the applied force, meaning we are going to have our frictional force going to the left, not to the right. I hope that's clear. So this is how to draw our force diagram. So number 2, they said determine the vehicle acceleration. For us to be able to determine the vehicle's acceleration, if there is a force applied, we need the resultant force will be equals to mass multiplied by the acceleration. And the resultant force will be the sum of the applied force plus the frictional force will be equals to mass multiplied by the acceleration. So let's say the direction to the right is positive, meaning the direction to the left will be negative. Our applied force is 200 Newton plus negative 50 Newton, which is the frictional force to the left, will be equals to our mass, which is 1000 kg, will be 1000 multiplied by the acceleration. Then we come and say negative times positive will be negative, meaning our resultant force will be equals to 200 minus 50, which will be equals to mass multiplied by the acceleration, which is 1000 a. Then when you punch on our calculator, 200 minus 50, it's 150, will be equals to 1000 multiplied by a. Since we are looking for a, we divide both sides by 1000. Divide both sides by 1000. 150 divided by 1000, we are going to get 0.15, which will be equals to a. And a, the units for a, which is the acceleration, will be 0.15 meters per second squared. What is the direction? To the right, because of right is positive, and our value of a is also positive. To the right. So this is how to answer the question if you are given a similar question to this one. Then the question, let's do a recap. It said a stationary car with a mass of 1000 kg. It was stationary. Then they said on that stationary car, the car is subjected to horizontal force with a magnitude of 200 Newton. There is a frictional force of magnitude 50 Newton between the surface and the car tire. Then number 1, they said draw a force diagram depicting all of the forces acting on the car. So since the car was on stationary and the car is not moving up and down, the normal force balances the gravitational force. Then once the force is applied to the right, which is the horizontal force, we show it on the diagram, it's Fa, and the frictional force always acts in the opposite direction. So these are all the forces acting on the diagram. Number 2, they said determine the vehicle's acceleration. For us to be able to determine the vehicle's acceleration, we need the resultant force will be equal to mass multiplied by the acceleration. How many forces are acting on the car? It's 2. Is the applied force and the frictional force will be equal to ma. Our applied force is 200 Newton plus negative indicated direction, which is in the opposite direction, minus 50 Newton will be equal to 1000, which is the mass multiplied by the acceleration. Then 200 minus 50, it's 150. Divide both sides by 1000. 150 divided by 1000 is 0.15, which will be our acceleration. Therefore, acceleration must have units. Is 0.15 meters per second squared. It must also have a direction, which is to the right. So this will be our question, and please try Please try the following question and we'll look at it in our next video. The question stated the following: a 5 kg box is resting on a horizontal surface. Determine the maximum static friction on the box if the coefficient of static friction is 0,800. Number B, a 50 Newton force is applied to the right and the box moves at a steady rate. Determine the coefficient of kinetic friction. So please try the following question. We'll look at it on our next video. Thank you for watching.